SwayamPrabha. Digital India. Educated India.
Welcome everyone to the NPTEL course on groundwater hydrology and management. This is week 2, lecture 4. In this week, we are looking at the importance of groundwater resources, both in the international forum and also nationally why it is important. We have already looked at and discussed in the previous lectures where groundwater is mostly occurring, where the aquifers are major and complex in nature, and which countries do take more groundwater for their agricultural industrial purposes. We did come across that multiple resources and multiple sources that groundwater is being extracted mostly in Asian countries, and of that and of the globe, India has the highest groundwater extraction, followed by US and China. And most of the groundwater that is extracted in India is for growing rice, wheat, and sugarcane. On this note, it is also important to look at the groundwater availability in India as per the Central Bank. And we did discuss that it is across major basins, it has been mapped. Last lecture, we looked at what percentage and how to read this table. And more precisely, we understood that most of the northern aquifers or groundwater basins are highly stressed. Anything above 50 is kind of concerning, and we need to take immediate actions to preserve the groundwater resources. Moving on, let's look at some case studies to see how the data do change or come in common agreement between studies and some of the international studies on groundwater use in India. As we know, there has been groundwater use mostly for non-monsoon season, because during monsoon you have the kharif crops where the crops get direct rainfall and they grow just by the rainfall in nature. Whereas in the Rabi season, groundwater irrigation is similar. So in this study, the researchers Chinnasamy et al. And looked at how the groundwater use was in Gujarat region, and they found that there is abundant of groundwater recharge in Gujarat, mostly when the dam structures and canal irrigation network was introduced. Because wherever the canal is going, there is a lot of recharge happening. It was also seen that the groundwater recharge is prolonged in these recharge networks, even though the other regions are not having enough groundwater. For example, in November, the northern regions did not have groundwater resources comparatively to the central regions where groundwater was more abundant in nature, relatively. And also, that also showed the picture that groundwater is being recharged and is available for agriculture. So now the study also looked at how the groundwater based irrigation was happening in 2003 and after 7 years. So the study found more and more crops grown during the Rabi season and winter season where groundwater is used. So there is more single crop in the Rabi and double crop also in the Rabi winter season, which means the same land is now used for more irrigation because of groundwater. Is this sustainable is a different question, but we do understand that groundwater has increased the number of times a land can be cropped. So during the rainfall season, you do have one crop, and during your groundwater irrigation season during Rabi and winter, there is a possibility of addition of 2 more croppings. Short crops, but it is possible using the groundwater recharge in these aquifers. So the study also found that during the irrigation scenario using the surface water, whereas the canal commands are there, the red in the Saurashtra region. All the water that is being sent down during using the canals are being indirectly reached by groundwater. So basically, the canal water was for supply of irrigation for crops. However, because it is not lined and there's a lot of recharge happening. And that recharge water can be used later during the non-surface water irrigation period for groundwater irrigation, the 1+1 crop and +2 crops. Also, another study from the same authors looked at how the introduction of groundwater wells in West Bengal, or liberalization in 2015, led to a sudden decrease in the net groundwater. So the study first started on the hypothesis by many authors and studies that the Ganges Basin is tremendous in nature, it's huge, so there won't be any issues in treating the groundwater because it will be recharging annually. However, the study clearly found a correlation between the number of wells that started to jump after 2015 because of the liberalization of the wells in West Bengal from 2005 to 2015, and the most impacts were seen in 2015. And the groundwater depletion. So if you could see, the groundwater was already stabilizing during the non-liberalization of the groundwater network. But after 2007 and 2008, when the number of wells started to increase, there was a gradual depletion of the groundwater. So the blue line you could see, the linear fit shows that the net groundwater level is declining. Total volume or thickness, however you want to put it. Here it is represented as equivalent thickness of water in centimeters. So the water levels or the storage is declining as and along the same pace as the wells are increasing. So we already looked at in previous studies that per well it's approximately around 11,000 meter cube per year extraction. And 20 million wells in India. So this graph can also give you the number of wells in West Bengal that were introduced and how much the water levels were declining. So there is a net decline in groundwater reserves wherever there is groundwater irrigation happening. It's not bouncing back. So if the well level are coming back up to the normal levels, then we will say you are using the water and is recharging. So there's no issues for groundwater in India. However, that is not the case. You clearly see in 2005, 2006, when it was introduced, it was stable. The groundwater level was all fluctuating because of the seasonal pattern, summer, winter, and rainfall, etc. It will come back to the same levels, hover around zero average, but then it starts to decrease. 2006 when the groundwater market was open. So both the recharge and discharge were seen here due to the irrigation plans. One is where you saw recharge because of the irrigation plans, and also another groundwater depletion because of a groundwater market opening for agriculture. Another study by Mishra et al. Compared that the area that came under different types of irrigation has changed dramatically from 1950s to 2010. It clearly documents that the number of tube wells have increased and or replaced the canal irrigation, which is a surface irrigation, the tank irrigation, which is also a surface irrigation given in orange line. Canals are given in blue line. It's almost stabilized, which means it's not increasing. What is increasing is the green line, which is the tube wells or wells that take groundwater from the aquifers for irrigation. So those have increased, and the area under the groundwater irrigation has dramatically increased. So the groundwater irrigation pattern has been shown in the figure A, where you could see the percentage of area, and mostly your north western regions, Gujarat, Rajasthan, Haryana, and the central regions of Maharashtra all show tremendous area under groundwater irrigation. And that's where most of the wells are being introduced. And there is also a comparison on how the energy is being used. There is electric pumps, diesel pumps, windmills, solar pumps, etc. So all these have been, as a result of industrial revolution, there has been a lot of technology and development for better pumping resources to access groundwater. However, it is not an unlimited supply of water. So you can invent all these pumps and engineering tools to take the groundwater out. But it is not something that is unlimited as they imagine. Groundwater is a limited source. So if you do not conserve and manage properly, the water is lost. Monitors these groundwater levels in India. It is the Central Groundwater Board, which is a government agency, and they make these very informative maps. This is a block and village diagram of India with boundaries, where you could see at a block level different colors to estimate the unit recharge of groundwater. Basically, this map has been done for the 2017 year, and this can be compared to the other data that we saw on groundwater basins, where groundwater occurs and how much water is being used. So if you look carefully here, the darker blue sections are where groundwater recharge is the high and highest in India, and occurs mostly on the floodplains or along the major river channels. So if you look at this, it is the Indus-Ganges Basin, and also this side is your Brahmaputra network, all having high groundwater recharge. But this is only recharge. It is not looking at the depletion and the net groundwater availability, this particular image. So what you also see is in some other regions in India, central and southern, a lot of blue color, which shows good groundwater recharge, and mostly in the regions where the water bodies are available, the Kaveri Basin, for example, in the south, and also regions where there is good amount of rainfall. Example, your Western Ghats, where the rainfalls can reach up to 3,000 millimeters per year, compared to central parts of India, where it is around 600 to 700 millimeters per year. So the unit recharge has been estimated every year, every 2 years, and Central Groundwater Board does put these levels across. They have around 15,000 wells spread across India, and they monitor every 4 months, quarterly intervals, and make these beautiful maps to show where the groundwater recharge is happening. So the hilly regions are not easy to access, so it is left blank or without any assessments. But most importantly, the smaller levels are present in central India, and also that's where all the irrigation also happens. So it is very important to understand where your annual groundwater recharge is happening. So based now on the extraction, so have your groundwater recharge, and you know how much water is being extracted based on the agricultural surveys, and also the water level after the irrigation session. As I mentioned, 4 times in a year they monitor the groundwater, and at one particular time they take it during the peak monsoon. So then the whole recharge is happening, the water gets into your groundwater aquifer, but after that they wait for some time, they wait for the irrigation to happen, the farming to happen, and then they take a level. So the difference between the level before the farming and after the farming clearly gives you how much water has been depleted. So now you have an idea of how much water came in and how much water has been extracted. We will get into the actual data and practices in the following classes. But right now I would like to just be focused on the topic, which is importance of groundwater in India and why we are studying this. So if you look at this map in particular at block level, you clearly see that a lot of blocks are overexploited. Allow me to define what overexploited means in this diagram. Overexploited means you are using more than 100% of your recharge. I hope you remember the 2, 3 lectures. We saw how the international agencies gave maps on how much water they extract and how much water recharges. So you do a ratio. If it is above 100%, it is overexploited. Up to 100% somewhere near is critical. 50-60% would be semi-critical, and safe is below the 50%. So what you clearly see here is the overexploited regions are really high, which is along the northeastern regions and also in the central regions where there's a lot of agricultural activities. The northeastern regions, northwestern regions could be tailored or understood because of the low rainfall and arid regions, whereas the other regions are purely depleting in groundwater because of tremendous use of groundwater resources. Also, Punjab, Haryana all have a lot of red color here. So overexploitation is a concern, whereas the other regions are safe. And you also have semi-critical, the blue color in some regions where slowly they are converting into the yellow, which is critical, and then red. So this is how they progress. If you don't take any action, the groundwater levels continue to decline. And at one point, the groundwater is extracted more than the annual recharge. So if you start taking water more than the annual recharge, you go into the overexploited scenario. And this is not a good way to use groundwater, especially in a nation where agriculture is the major occupation of the people. And agriculture also takes a bulk of all the groundwater reserves. So it is very, very important to understand this diagram very clearly, which is based on observation data taken every 4 months and also assessment of the recharge. So they know how much recharge is there and they know how much water is being extracted. If your recharge is less than your groundwater extraction, then you are over exploiting your aquifer or the water in your block. The other thing that you could clearly notice here is the red blocks do not isolate themselves, or in other words, it is not a scenario that occurs just in one location. It is a combined effect, or it is a localized kind of scenario where multiple blocks take part in this groundwater depletion. So if you take one water and you deplete and continue to deplete, you're not pulling your own water, but also the water from the neighboring blocks. Recharge may be very localized. You can see blue color in some blocks and then it's localized. And because of the blue color around the neighboring blocks can also get water. Same way, the red color indicates that it is overexploited. And once when a block is overexploited, it can easily pull water from the neighboring blocks, thereby increasing the radius of your red color, which is overexploited. So unless the water conservation activities do not kick in, your groundwater reserves would be gone. And this could be through government activities or community activities that we saw in the previous slides. So moving on, water stress has been calculated by the WRI, and they clearly mention tremendous water stress occur in the central and northeastern regions, also in mostly in the northwestern regions. And the western regions constitute the Rajasthan, Gujarat, Punjab, Haryana, Delhi, etc. The regions could be very different as per the blocks. For example, these could be due to agricultural activities, whereas your critical and semi-critical regions along Bangalore, Chennai, and Hyderabad could be because of tremendous use of groundwater for industries and domestic use. Even though agriculture is the major user of groundwater, in local urban settings, if the groundwater recharge is not happening, you are depleting your groundwater aquifer. And that is also shown in this image, that suddenly when you have a combination of a lot of urban settings, your recharge is coming down. So once your recharge is coming down, you cannot use the groundwater based on historic recharge values. You will have to reduce your recharge groundwater consumption rate so that your groundwater is preserved. The other thing that is very important to notice here is that the hilly and forested areas are not monitored as regularly because groundwater may not be pumped, and the blocks wherever the 15,000 wells are present may not capture the exact pumping scenario. This is because some of the wells are isolated from the groundwater pumping areas, and due to regulations and stuff, and or they're concealed. Unless the government would take in the groundwater well record from the farmers, it will not be more representative. So it is very important to understand that still there is a space for improvement on groundwater monitoring, and it will be good to use representative wells. This figure is also showing that the cropping pattern also drives the groundwater abuse or groundwater extraction. So these regions are mostly cultivating wheat, whereas these regions cultivate rice. So there is a strong correlation between the water use and the crop that they grow. In addition, there is also a correlation between the blocks of groundwater overexploited blocks in correlation with the rainfall. So if you see here, along this coast where you have the Western Ghats and 3000 millimeter rainfall, it is almost safe and less critical. Okay? The water levels are safe, and no one worries about too much groundwater extraction. Whereas these arid regions where there is groundwater less in the aquifer and also rainfall is less, you cannot be using the same water demand scenarios. This is where overexploitation happens. So you can look at overexploitation in multiple angles. Is it because the groundwater is being exploited too much, more than the annual rainfall, or the annual rainfall is very less, and that is why people go for groundwater recharge? Either way, the groundwater recharge cannot sustain such activities, and also groundwater reserves are not unlimited supply, which means it will run out dry soon. As you would have noticed, a lot of wells have run dry, and your agriculture pattern has to change. This beautifully lists along with your WRI image on 2013, looking at the baseline water stress, where red color indicates a tremendous water stress. And if you map this along with the water blocks from CTWB, you can clearly see the match. So the study used data from multiple sources and also surface water and groundwater together. Okay, so this is image on your left, looks at total water stress and says that high to extreme high water stress is going to be hitting pretty soon in the northwestern region, and also the central and southern regions and along the coast. If you compare this with the groundwater block assessments as per CGWB for the year 2017, now almost the years are comparable. 2019, the study came out on the left, whereas this study from CGWB also came out in 2019 for the year 2017. So what you could see here is that the blocks are in correlation or in agreement with the WRI indicators of water stress at a state boundary. So Rajasthan is on the red color, where the water stress is high to extremely high across the state. And that also corresponds to really overexploited scenarios in the groundwater. So the stress is already there. the baseline stress, and the groundwater is low. So unless you recharge and reduce your groundwater and water stress, your system cannot sustain such activity. Let's take other examples where there is red and not much groundwater exploitation. So along the eastern coastal regions of Odisha, Chhattisgarh, etc., you could see that there's not much groundwater depletion. However, there is potential for water stress. This could be because of tremendous amount of floodings and cyclones that hit that area. And if you come down on Karnataka, Andhra, Telangana, and Tamil Nadu, Kerala regions, you do see tremendous stress that is being predicted by WRI, both in surface and groundwater, which is also in agreement with your assessments in Central Groundwater Board. The Karnataka belt, Bangalore, etc., have been tremendously hit by groundwater exploitation, and also some parts of northern and central Tamil Nadu have shown some critical and overexploited blocks. Thereby, both these different studies and different data are in agreement that the surface and groundwater resources are depleting as per WRI, and 54% of India is going to be under high to extremely high water stress, whereas the groundwater board has estimated that most of these regions also will experience a groundwater depletion scenario. So if the stress is high and you don't have groundwater, it is going to be a very scary scenario. So the concern is being raised in this course, and also you would be taught how to manage groundwater, so that even though you are projected to have a high water stress, if your groundwater reserves are good or in a positive blue color, then you'll be able to sustain the groundwater depletion scenario. So with this, I would conclude this week's groundwater lecture, importance of aquifers and groundwater systems globally, and also in the Indian scenario. We will also look at some case studies in the next, and we will wrap up this week so that we could start getting into the physical hydrology part. Would explain the concepts of aquifer, block level estimation, how do you estimate your groundwater levels from the top, and make these graphs on groundwater depletion scenarios. You will also look at some quick models, an introduction to models, to see how you could estimate groundwater depletion scenarios based on the well record. So for example, this Central Groundwater Board has given you the well record and have mentioned where the water levels are more in the recharge and also on the depletion scenario. And that can be incorporated into these models along with other data like climate change, rainfall, to estimate the future groundwater scenarios, which is very important to manage. So with this, I look forward to this week's lecture on the importance of groundwater across the world, and more specifically, the importance of groundwater in. Let's see you in the next class. Thank you.